Take a look at Poisson distribution. Now, the reason we have so many distribution is because every distribution has its own function. It's like a specific tool for a specific item. Now, whenever we are talking about the Poisson distribution, we are actually talking about a type of distribution that can be helpful for events that happens on an average. That means, for example, when we talk about an earthquake, when we talk about the probability of an earthquake occurring, well, it might never occur. Or when we talk about the probability of an accident occurring, or for that matter, we are talking about the profit of a business, that might never occur. So when we have an event like that, which might never occur, for example, when we toss a coin, a head or a tail has to happen. It is something that will happen. We know that either one of the two will happen. But in case of Poisson distribution, something that might never happen, how do you know about that? Well, we always talk about here on an average. So that's the key to this, on an average or the mean. So what happens on average? So if you want to know what is the probability that there will be an accident in this road, so you have to see the history. What happened in the past on an average. So the Poisson distribution is actually having the assumption that whatever happened in the past, that is going to happen in the future as well. So if someone tells you how will the Poisson distribution take place, well, the reason for using a Poisson distribution, the events should occur singly. That means one at a time. We cannot have simultaneously 30 accidents and we cannot consider it. It has to be one at a time, independently. That means if one accident occurs, that is the reason for another accident. No, they have no connection to each other. That's independent. Independently means that can happen together, but that does not necessarily meaning one is affecting the other. For example, if someone has a birthday and two friends give the same gift, now that thing can occur, but the fact that they gave the same gift did not have any connect. It might be a coincidence, but one person did not affect the decision of the other person. It happened independently. And the third thing is constantly. That means we have to assume whatever the average we are getting, that average is going to be constant. It is going to be constant. We cannot say that, okay, this is the average, so on an average 5 accidents occur every year or every day. Now, to say that it happens constantly, it means if you think that in one day 5 accidents occur, you can multiply it with 30 and say in 1 month how many accidents occur. So you can just multiply it, have an effect, a constant effect. So we have to assume even occur constantly, otherwise how can we do the sum? So that's an assumption that we are making while doing Poisson distribution. Now the next question, after we know why to use a Poisson distribution and when to use a Poisson distribution, one thing we have to start with is talking about a distribution. We have to understand a distribution is made up of random variables. So the next thing that we should talk about is the random variable itself. So in Poisson distribution, the random variable, let me call the random variable x, is defined as number of events that occur per unit. That means number of accident per day. So the event is the number of accident. The event, what is the event? It can be something that is happening. It can be number of earthquake, number of accident, number of shoes sold, number of people present. But one of the most important thing to remember is the unit. This unit is extremely important. It means if the unit changes, the random variable will change. So the unit thing is extremely important. Now the next thing that we talk about is the distribution. Well, Poisson distribution has a random variable that is discrete, so it is important to remember that the random variable itself is a discrete random variable. So this is discrete. It's a very important concept. Discrete meaning countable. So countable. So whatever happens, the random variable must be countable, so events are countable. So this is a discrete random variable. Now the next question is the probability. How do we find the probability? For finding the Poisson distribution, we have a formula for finding the probability. That thing is called the PDF formula, meaning the probability distribution function, or the probability distribution formula. So the PDF meaning probability distribution function or formula for Poisson distribution is this. So probability of, let me call the random variable capital X, which I have already mentioned, equal to, and the value of the random variable small letter x. So the formula for finding the probability of the Poisson distribution is e to the power minus mu, which is the mean, then mean to the power x divided by x factorial. Factorial means something that is multiplied backwards. For example, 5 factorial means 5 into 4 into 3 into 2 into 1. That's what it means. The funny thing is 0 factorial is actually 1. 1 factorial is actually also 1. So this is one of these strange math things that people do to make the math work. Anyway, now for talking about how to find the formula of the probability, we have to talk about the probability itself. Now you have to understand, this is a formula that you seldom have to use. Usually all this formula has been written and formed in a form of a table, the Poisson distribution table. In the Poisson distribution table, all the values of the random variable with their, you see this formula has two things. One is the random variable x, this x thing, so that's one of the thing, the random variable, and the other is the parameter, the mean. I think it's time to define the distribution itself. The distribution is defined like this: the random variable x is distributed by the Poisson distribution given by PO, and with the parameter mean. So that means the parameter of the Poisson distribution, for doing the Poisson distribution sum, the most important thing is the mean itself. So if you take a look at the Poisson distribution table, all you need is the mean and the random variable for finding the probability. For example, there are 5 students in a classroom. So if there are 5 students in a classroom, so what can happen actually? You want to find the number of students who are present. So it occurs singly, one student come at a time, independently. The absence or presence of one student does not affect the other students, assuming it doesn't affect, and it occurs constantly. So if we think about the random variable as something that an event where the students are present, so we can say x equals to number of students present. But the sum is not done because we have to talk about the unit. Suppose it's talking about per day, because it's a class. So how many students can be present per day? Well, first of all, maybe no one is present out of the 5 students. 1 person is present, 2 person is present, 3 person is present, 4, or everyone is present, 5. And the probability it can be found using this formula. So we can actually put the value of 0 here, so it would be e to the power minus mean. The sum might be given from past history, from the history, that the probability of a person being present is, suppose, not probability, on an average 3 people are present every day. So from that, per day 3 people are present, we can use mu equals to 3. So that can be found from the past. So we can fill out all these values. So that's in a nutshell the concept of a probability distribution. So let's take a look at a sum of a probability distribution.